All right, welcome to The Explainer. Today, we're going to pull back the curtain on the blueprint that teaches an AI how to think. How it can look at a super complex problem and somehow see a clear map to the best possible outcome.
So, have you ever wondered how an AI actually learns to master a game, or navigate a robot through a messy room, or even trade stocks? It all boils down to this one big question. How do you teach a machine not just to follow a rigid set of instructions, but to actually make the best possible decision all on its own, especially when things are, unpredictable?
Well, the answer is something called the Markov decision process, or MDP for short. Now that sounds complicated, but don't worry, we're going to build this blueprint together piece by piece. And it all starts with one single, incredibly important rule that makes the whole thing possible. So, let's dive into that.
Okay, so the entire system, the whole shebang, is built on this one core idea. It's an assumption that honestly dramatically simplifies the world for an AI and lets it focus only on what truly matters.
It's called the Markov property. And put simply, it just means that the future is independent of the past, given the present. What does that actually mean? It means what happens next depends only on where you are right now, not the long, complicated, messy history of how you got here. Everything you need to know is packed into this very moment.
So think about what this does. It lets the AI just drop all the baggage from the past. It ignores the complete history of every single step and focuses only on its current situation. For a chess-playing AI, this is huge. It doesn't have to remember the last 50 moves in sequence. All it needs is the board, right now, to figure out the best move to make next. It's incredibly efficient.
Okay, so with that rule in our back pocket, our first step is to actually map out the AI's world. And to make this really easy to grasp, we're going to use a great analogy, a student just trying to get through a course.
So here's the student's world. These are all the possible situations, or what we call states, they can be in. They could be in class 1, class 2, maybe procrastinating on Facebook or hanging out at the pub. Each one of these is like a location on our map. And you'll notice pass and sleep are what we call terminal states. Once you land there, the game's over. The journey is done.
But here's the catch. At this stage, the world is pretty random. Our student is just a passenger, they're not driving the car. The world just kind of pushes them from one state to another based on probabilities. So for example, from class 1, there's maybe a 50% chance they'll actually go to class 2, and a 50% chance they'll get distracted and, whoops, they've ended up on Facebook.
So you can imagine one possible journey, right? They start in class 1, then move to class 2, then class 3, they pass the course, and finally, they get to sleep. Phew. That's just one sample path, one story that could unfold. And this map, this collection of states and random transitions, that's what we call a Markov process. Okay, so a map is great, but a map doesn't tell you where the treasure is buried. It doesn't tell you where you want to go. To do that, we need to add some value judgments, or what the AI world calls rewards.
So we start assigning a score to every single state. Being in class, that's a -2. It's a bit of a drag, it takes effort. Checking Facebook, -1, not great. But hey, going to the pub, that's a +1, a little bit of immediate fun. But the real prize, the treasure on our map, is that huge +10 bonus you get for passing the course. That's the goal.
And here's a key idea. The goal isn't just about grabbing the next immediate reward, like that quick +1 from the pub. It's about maximizing the total return. That's the sum of all the rewards you collect over the entire journey. And often we discount future rewards, meaning a reward right now is worth a little more than a reward way down the line. By adding these rewards to our map, we've upgraded it. Now it's a Markov reward process.
Okay, so far our student has just been a pinball, bouncing randomly around this map, collecting points. But now it's time for the game changer. Let's give them the steering wheel.
This is the final crucial piece of the puzzle. We're adding actions. And this is where it gets really cool. Because instead of the transitions being totally random, our agent, the student, can now choose an action that directly influences where they go next. For instance, when they're in class 2, they have a choice. Do I study harder and get to class 3? Or do I just fall asleep and end the journey? Later in class 3, another choice. Study to pass the course or go to the pub. See? They're no longer just victims of random chance. Their choices matter. And by adding this layer of agency, we have finally built a complete Markov decision process. Now, this leads to a new concept, the policy.
A policy, you'll see it written as the Greek letter pi, is just the agent's strategy. It's the rule book. It's the plan that tells the AI what to do in any given state. So a studious policy would be a simple rule book that says, hey, when you're in class 3, you always choose to study. No pub for you.
All right, let's recap. We've got our map of states, we've got our treasure, the rewards, and now we've got choices, the actions. The whole reason we built this entire blueprint is to solve one single ultimate problem. How do you find the absolute best plan?
And that's the whole goal of this field called reinforcement learning. It's to find what's known as the optimal policy. We're not just looking for a good path through the map or an okay strategy. We are hunting for the one single best strategy that will absolutely maximize the total reward over the long haul. The perfect plan.
So for our student, what does that look like? Well, the AI would analyze the whole map, all the states, all the actions, all the rewards, and it would discover the optimal policy. And it would look something like this. In class 1, you study. That gets you to class 2. In class 2, you study again, getting to class 3. And in class 3, you study one last time, you pass the course, and bam, you get that plus 10 reward. That right there, that is the solution to the MDP.
I love this quote from David Silver, a pioneer in this field. He said, "The entire game is to find the best path through your decision-making process that maximizes the sum of rewards." And that's the absolute key takeaway. This whole framework, states, actions, rewards, it takes a messy, complex problem and turns it into a solvable map. A map where an AI can actually, mathematically find the very best way forward. And think about it. This isn't just for a hypothetical student. This is the blueprint for optimizing medical treatments, for managing a global supply chain, for teaching a robot to walk. It gives us an incredibly powerful way to find the best path forward in a really complex world. So it leaves you with a question, right? If you could map out any decision process like this, what problem would you want to solve first? Thanks for joining me on this explainer.